This is a video walkthrough of section 1 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. Differential calculus is all about differences. We have to wrap our heads around the difference equation because difference equations are rare. Pre-calculus, they are all normal equations. We're going to try to get an understanding of difference equations using the perimeter of a square. It's nice and simple. A square has 4 equal sides. If we define the length of one side as s, the perimeter is 4s. There's a square. Each side length is s. The distance around is 4s. So the normal equation that relates to variables themselves is p equals 4s. That's what you're used to, normal equations. So if we have a square dog pen that has sides that are 10 feet long, you're going to need 40 feet of fencing around the perimeter. What is the difference equation? The difference equation relates differences or changes. If you have two different squares, you can talk about it as a difference. If you have one square that's growing, you can talk about a change in the length of the square. So think about it. Here's a square, perimeter is 4s, side length is s. Here's a different square. The side length is s plus delta s. It has a different perimeter. What is the difference in the perimeter of those two squares? Think about it. If you have to, pause the video. The difference equation is delta p is 4 delta s. The capital Greek letter delta indicates change. This should make sense. It should not be magic. Of course, it's delta p equals 4 delta s. If I add a foot to each of the sides of a square, the perimeter goes up by 4 feet. So let's look at a relationship between the perimeter and the length of a side on a graph. This is essentially a map of the normal equation. It gives the perimeter for any side length. So for example, if the side length is 2, the perimeter is 8. There's 4 sides, each is 2 centimeters long, the perimeter is 8 centimeters. If the side length is 5, the perimeter is 20 centimeters. If the side length is 8 centimeters, the perimeter is 32 centimeters. This is the normal equation. This tells us the p for any s. The straight line is a line of the normal equation. The normal equation is p is 4s. Now let's switch gears and focus on differences. The difference between the square length, a square that has side length of 5 centimeters and a square that has a side length of 8 centimeters is 3 centimeters. That's delta s. The perimeter is 32, and the perimeter here is 20. The difference in the perimeter is 12 centimeters. So delta p is 4 delta s. You can use any two squares. Let's use the other two. Here we have a square of 2 centimeters side length. Here it's 5, the difference is 3. The perimeter here is 20, the perimeter here is 8. The difference in the perimeter is again 12. Delta p is 4 delta s. Now let's think about the slope of the line. The slope gives us the relationship between the changes. The slope is the rise over the run. The rise is delta p, there it is. The run is delta s. And since the slope is constant, we can use any delta p or delta s. We can use a big one here. Delta p is big, delta s is big. We can use a little one there. Delta p small, delta s is small. The ratio is always the same. What is that ratio? Well, we can use these 2 points because we know the numbers. Delta p is 12, delta s is 3. 12 centimeters over 3 centimeters is 4. The slope is 4, and it's always 4. So that's an introduction to difference equations. They're different from normal equations. We have to wrap our head around difference equations if we're going to understand differential calculus. So here's some takeaways from section 1. Difference equations relate the difference in one variable to a difference in the other. In this example, difference in side length to difference in perimeter. If you graph the relationship, it's nice. You get the normal equation, tells you how the value of one is related to the other, and you can also get the changes from the slope. So we recommend doing the exercises and problems at the end of this textbook, at the end of this chapter, end of this section 1.1, so you can get used to difference equations. You are on your way.